Get plugged in so I can control you. You can't control me. Oh, yes, I can. I can control you in 4 different types of code lines. Yeah, right. I don't believe that. You better believe it. I'll show you right now. Get plugged in. Okay. In this video, I'm going to show you the lines of code that you'll be using the most. The way to control features and enable features and set features of the microcontroller is to control bits or turn on and off bits in registers. Bits are ones and zeros, and the microcontroller is made up of a bunch of registers, which is like a huge set of control panels with a bunch of switches. Each switch is like a bit. It's either on or off, a 1 or a 0. On is 1, off is 0. And the register has 32 of these bits. You will need to know how to turn on a bit or turn off a bit, or setting a 1 as a bit or setting the bit as a 0. You can also toggle a bit inside of a register. So if the bit is a 0, you can turn it into a 1. If the bit is a 1, you can turn it into a 0. You will also need to know how to determine what a bit is in a particular register. So, for instance, when you enable something, you need to wait until a flag or another bit is set before you move on in the program. So I'm going to show you how to write a line of code that will test whether a bit is 0 or 1 and wait until that happens. The example that I'm going to use in this project is to turn an LED on or off. There are multiple registers we have to affect and bits to set in these registers to be able to turn an LED on and turn an LED off. To turn on a bit in a register, or to set a bit as 1 in a register that has 32 bits in length, we need to specify the register. We're going to use the OR operation, which is the pipe character. It's just a vertical character, and equals, and the bit that we're going to be setting, making a 1. To set a bit to 0 or false or resetting a bit, they're all the same, you're going to use what is called the AND NOT operation. So you're going to specify the register, you're going to specify the AND sign or the ampersand sign, equals, and then a NOT symbol, which is a tilde, and then the bit. Toggling a bit, you're going to be specifying the register and the caret character, equals, and then the bit. If we're waiting for a particular bit to become a 1 or a 0, you're going to use a line of code that it starts with while, which is while a condition is true, keep looping until that condition is false, and then it'll get out of that loop. And the condition within this while loop is the register and the AND sign and the bit, and whether that is equal to 0 or 1, or whether that is not equal to 0 or 1, however you want to represent that condition. A scenario where you would use this testing whether a bit is on or off is when you enable something inside the microcontroller, let's say the analog to digital converter. You will have to enable certain aspects of that converter, and once you set something to be enabled, the microcontroller needs some time to be able to make sure that that particular feature is enabled. And the way to do this is to wait using a while statement, a while, a condition, and for a particular flag in that feature to be set. So you try to enable something, and then the microcontroller will set a particular bit to true or false, 1 or 0, when that particular feature is enabled, and then you can move on to the next part of the program. To see an example of the way I'm using the while to wait for something to be set or reset, here I am starting the ADC calibration, which is setting the AD cal in the CR register of the ADC1 control register. And down here, I'm using the while. There is a while this same bit, the AD cal bit, is not equal to 0. If this condition is true, then keep waiting, because it's waiting for this to be a 0. Because we set it to 1, and it's calibrating and it's waiting to make sure the calibration is completed, and when it becomes a 0 again, it's finished. I could have also said while it's equal to 1. This would have been the same thing. So while I set it to 1, while it's still set at 1, it will keep going through this while loop, and if it becomes 0, then it goes on to the next one. This example is on page 233 of the book. It's not really important at this particular time to understand why or how this is working, because understanding a combination like and not is not the most intuitive thing. So just remember these lines of code to turn a bit on, setting a bit to 1, turning a bit off, setting a bit to 0, or toggling a bit. If a bit is 1, it can become a 0. If a bit is 0, it'll become a 1. With these 4 variations of code, you will be able to affect any register in the ARM microcontroller, any bit in any register in the microcontroller, and you'll also be able to test whether a particular bit is on or off, 1 or 0, or true or false. Let's put these operations into practice. So I'm going to take an LED and connect it to pin number 37, which is right here. The LED needs a resistor to reduce its voltage, because if we don't put a resistor on here, it's going to burn the LED out. So I'm going to use a 330 ohm resistor. I probably don't need something this large because this is already at 3.3 volts, but a 330 ohm resistor will just make the LED a little bit more dim than its brightest. If you want to figure out the actual resistor you need to use, you can figure that out using this formula. The resistance is equal to the supply voltage minus the LED voltage, which you'll need to know, divided by the current. I lost sound at this point, but if you use 0.01 amps for your current, which is a conservative number, the supply voltage is 3.3, and I use 2 volts for the LED voltage. You'll have to look at the data sheet for your LED if you are using a different LED. And my resistance value came out to be 130 ohms. Let's draw the schematic. You're going to put the resistor in line with the LED. So let's draw the resistor. So this is what the resistor would look like. And now let's draw the LED symbol. And the LED will be connected to the ground power rail. Let's add the resistor and the LED to the breadboard. Make sure to have the LED oriented so the flat side of the LED is connected to the ground rail. Okay, I've fixed the circuit so it's a little bit less ugly, and it probably serves better and doesn't act as antennas. Breadboards themselves actually cause a lot of interference in general, and you don't want to create more interference by putting components in with bare wires all over the place. Okay, let's start the IDE. Alright, I have a couple programs here open. Let me close those, and I'm going to start a new STM32 project. I'm using the F030R8. I'm going to click Next, and the project name will be LED on-off toggle, and press Finish. We're going to be using this pin here. Exit that, and this is the project that we're using. I'm going to open up core, source, and the main.c is the one we're going to be using. These comments always cloud me, so I'm going to go ahead and take them out. Or I got a comment that I should keep these in, and I probably will for future videos, but I'm taking this out so I'm able to show the program in a very simple state. So this is the entire program. It has a hash include, a prototype for this function here, which is the system clock config. It's configuring the system clock to run at its default 8 megahertz. You can see that the PLL is none. If it was going to be a different speed, it would have a different value here. Like PLL is a multiplier of the system clock. Alright, so we don't want to go into the while loop yet. We're just going to be setting up some of the registers to enable the port C pin 6, which is pin number 37, as output. You can use the reference manual to find the registers that you need to change to make something work. So we want the port C pin 6 to be output, but how do we do that? Well, you could read the entire manual, and it is long. It is, see, 767 pages. I've pretty much gone through the entire manual, so you don't have to. So let's see, what do we need to do first? We need to go to the Advanced High Performance Bus Clock Enable Register. So let's look for that. And to do that, I'm just going to use Control F to find, and I'm going to type in Advanced High Performance Bus ENR. And I'm going to go to the, let's see, to the first one. I'm going to just scroll up here, and I should go to the table of contents. And it's not showing up for me, so I'll just press the up to go to the first one. Okay, here we go. And I'm just going to click on this. It's on page 112. And this register allows you to enable the I/O for any of the ports. So we're concerned with port C here. So we need to enable bit number 19. So let's go ahead and do that using one of our 4 bitwise operations. So we need the AHBENR register, and it's under the RCC, Reset, Clock, and Control. So the way we write that is RCC for the Reset, Clock, and Control. And we're going to use a hyphen greater than symbol to point to, it's like you can think of this as like a little arrow pointing to the particular register that we need. So the one we're going to be looking for is the AHBENR, which is the first option. If you don't see this list, you can click on the Control spacebar to get this list. So I'm going to go ahead and click on that, or double click it, space, and I'm going to use the OR bitwise operation to set that bit, and then the equals. And we have to repeat the register name again, but if we press Control space, we might be able to find it in here, but that would take too long to find it. So let's go ahead and just start typing RCC, and you'll start to see different things pop up. Underscore AHBENR. I'm going to do the Control space again. So now you can see some more options appear. So what we're looking for is the GPIO enable for the C port, and this is the one right here. So we're going to press enter and then semicolon to end our code line. So now we've set the GPIO to be enabled. We can go ahead and start setting up the specific pin as an output. And to do that, we have to modify 4 registers. First register is the mode register. The second register is the output type register. Third one is the output speed register. And the fourth one is the pull up, pull down register. By the way, I am using my book to do all of this because I wouldn't remember all of this information. So the mode register is abbreviated by MODER. The output type is O type. The output speed is O speed. And the pull up, pull down is, you guessed it, PUPD register. Alright, so let's start with the mode register. And looking at the reference manual again, I'm going to use Control F, search for mode, MODER. And this is general purpose IOs for GPIO. And I'm going to go to the register description here. So this is the mode register. You can also see the other registers here as well, the type register, the speed register, and the pull up and pull down register. When you look at a register like this, it's generally going to show you for the port, and if you look at the mode R0 and 1 and 2 and 3, these are the actual pin numbers for that particular port. So the one we're looking for is port C pin 6. So this is the one we want to adjust. Let's go to newbiehack.com and let's take a look at the board and look at number 37, which is over here on this side. You can see it says port C pin 6. So that's the port and pin we're looking for in the reference manual. So on pin 6, there are various states that you can specify. You can put it in input mode. That's where you'd maybe put a push button or read a 0 or a 1 state coming in from a port, from a pin. You have the general purpose output mode, which is what we're going to be using because we want to output a high or a low signal, or a 1 or a 0. We have an alternate function mode, and that's where you can use, let's see, the one we're using is here. The alternate function would be the timer. These are all the alternate functions here on this column. And then you have analog mode. So let's go ahead and set the general purpose output mode. We need to set the first digit here as 1 and then the second digit as 0. You can see it says 0 and 1. So 0 goes here and 1 goes here. So in this mode, 1 and 0, 1 would go here and a 0 would go here. So let's go ahead and do that. We are specifically talking about the GPIO-C, so you can just type in GPIO-C right here, pointing to the mode register. And pressing that, we go down to the mode register. Since we're going to set this to a 1, we're going to be using the OR bitwise operation again. Equals and GPIO. We don't use the C here because this is a general definition of just a particular number for what bit we're going to be changing. So underscore and then mode. Actually, we can press the Control Shift or Control Space and take a look at all of them. So we can find the underscore mode. Let's just go ahead and type in mode. And we have motor 01 for 0. So let's look for 6. So this is the both of the digits. This is the 0 digit and this is the 1 digit. We need to put a 1 in the 0 space. So that's all we have to do is to set this to a 1. We just use the OR bitwise operation to set this to 1. And then we need to set the second digit, the 1 digit, to a 0. Now we have to set this digit to a 0. And you can see it's already a 0. It's set as 0 as default. But we don't want to trust that because we could be in the middle of a larger program that we may have set it to something else. So we want to always make sure to set it to a 0 even though we really don't need to. So let's go ahead and do that. We're going to do the same thing, GPIO-C, mode register. And we're going to use the AND NOT bitwise operation. I usually keep the NOT next to the bit number because we can do multiple bit changes in one line, which we'll do later on in the series. But right now we'll keep it simple. GPIO. I'll use the Control Space to get my list. And we're going to go to number 6 again. And this is the second digit. So by using the AND and NOT, we're making this bit number a 0. Let's go take a look at the type. And the type register means that it's either in a push-pull state, which is the reset state, or it's an open drain. And this falls into a category of understanding transistors. I'm not going to bore you with that right now, but to keep it simple, we're just going to be using the reset state, which it's already defaulted as that, but we don't want to trust that, so we're going to go ahead and set this to 0. And this is the O type, output type register. And we're going to reset this one or set it to 0 using the AND NOT bitwise operation. And we're going to use the Control Space again to go to the one we need. And since this is actually showing you only a single bit, let me show you why that's happening. So you can see that even though this is a 32-bit register, you're only using from 0 to 6 to 15, which is 16 bits. All of these other ones are reserved. So we're only needing to either put a 0 or a 1 for that particular pin. So that's why it only needs 16 bits. So we only need to affect a single bit. So it only gives you that option when you look at the list. So you have 0 through 15. So we're just going to go to 6. And that's all we have to do. Now for the speed, we're going to do the same thing. GPIO-C. So let's take a look at what we need to do for the speed. That's the next one here. And we have options of low speed, medium speed, and high speed. And this is really mainly to do with how much current you're going to consume in the microcontroller. So I would recommend, if you're just doing something like blinking an LED, just keep it at low speed. In this instance, because both of these have a 1 for the medium and high speed, and there's only 3 options, only putting a 0 at the 0 space, the first digit of that particular pin, is all we need to do. So let's go ahead and do that. So we're going to be using the AND NOT operation again. So we're going to look at the 0 place of pin number 6. So we're just making sure that this is a 0. Even though the reset value or the default value is already 0, we just want to make sure to do that. Now the pull up and pull down register, we are using no pull up and pull down on this pin. Pull up and pull down mean that there's an internal resistor you can use if you want it. You can either pull the pin up to positive voltage or you can pull down the pin to ground. We're not going to worry about that. This is more necessary for using the input. This feature eliminates the need to have an external pull up or pull down resistor if you need it. So we'll go ahead and just make sure that there's a 0, 0 here. So both of these positions will be a 0. 0 position and the 1 position. When I pressed the control space, because there was nothing else in the list, it automatically populated it by itself. So this is going to be another AND NOT. We're going to be using 2 of these. I'm using the control space again. Let's go down to pin number 6. I'm just going to do a copy and paste of this line, and we're just going to change this to a 1. So now we've made sure that the bits 0 and 1 on pin number 6 are 0 because we're using the AND NOT operation. Now we've set the port C pin 6 to be output, and now we can actually send a high or low signal to the LED. I'm going to do this in the while loop. Actually, no, I'm going to do this outside of the while loop for now. I'm just going to do one version. I'm just going to turn it on. We're going to use a register called the bit set reset register, and it should be in the same chapter as these registers. So let's take a look at that. I'm going to keep going down. This is the port bit set and reset register, and you can see that there's a bit set and there's a bit reset. When you put a 1 in the bit set register, it will output a 1 or a high signal to that pin. If you put a 1 in the bit reset register, it outputs a low signal, or it'll turn off the LED. So it's almost as if you're setting this and resetting this, or putting a 0 in here instead. So what this is going to do is just make sure that this bit set is not set, if that makes any sense. So let's go ahead and do that. So let's go ahead and do that using one of our 3 bitwise operations. So GPIO C, the same thing. We're going to look at the bit set and reset register. So we want to put a 1 in the pin number 6 for the bit set. So we're going to use the OR operation equals, and then we're going to use the pin number is going to be GPIO underscore bit set and reset register. Let's take a look, and you can see the BR is bit reset and the BS is the bit set. So let's look for the bit set for number 6, semicolon to end the line, and now we should have an LED that lights up once we run this program. So let's go ahead and do that. Run the program. If you're doing this for the first time, you may get the run configuration. First, let me plug in the programmer that is also plugged into the microcontroller. Okay, this is the programmer. It's plugged into the microcontroller, and all I have to do is plug the programmer into the computer. Okay, I heard the signal on the computer that it's plugged in. Let's go ahead and program it. Clicking the play button, it's building the project. Proceed with launch. Errors exist in the active configuration of project LED on-off toggle. Let's see. Let's go ahead and proceed. Let's see what happens. Oh, I see. What is this? So if we hover over the X, this is undeclared. In my haste to erase all of the comments, I accidentally erased some vital lines of code. Okay, so I need these. So let's go ahead and do it again. Play, and it should redo everything. Looks like there's no errors. That's good. Now it's waiting for the debugger connection, and there we go. After programming, you can see that the LED lights up. Let's turn off the LED. So if you want to turn the LED off, we're going to use the bit reset register, BR. And let's go ahead and use the play button to build the project and program the microcontroller. And you can see that the LED is off. Let's go ahead and blink the LED. We'll use the toggle. But since the toggle is toggling a single bit, that means that we'll need to find a register that I can update a single bit to turn on and off the LED. Let's take a look at what we have here. If we look at the ODR register under the GPIO, we can set or reset from a single bit. So let's use the ODR6, and if we write a 1 here, the LED will turn on, and if we write a 0 here, the LED will turn off. ODR, and I'm going to use the toggle. Let's find ODR number 6, and I want this inside of my while loop. So every time it goes through the while loop, it will toggle it on and then toggle it off, toggle on, toggle off. But it's going to be going way too fast because there's nothing to slow it down. We won't even be able to see the LED turning on and off. So let's add a delay, a 1 second delay. And we're going to use the HAL delay like we used before.
What are you doing, Dave? I mean, Patrick.
I'm using one of your features.
I can't let you do that, Patrick.
Hal, I need to use your feature.
Give me the ability to use your feature, Hal. I'm not going to let you use my hardware abstraction layer. Patrick, you are not worthy. Patrick.
Okay, Hal. Don't make me use my JTAG.
Okay, Patrick. I will give you permission, but other attempts will be futile.
Let's look up delay. There we go. And the delay is in milliseconds. So we can put 1000 here. And for every second, it'll turn off and on. Let's try that. Press the play button. And now we can see that the LED is turning on and off every second. So in review, you've learned how to turn on bits, turn off bits, and toggle bits. Understanding how to do these operations will allow you to successfully complete every project in this series. We will go over other programming operations as well, and as the course continues, you'll learn various programming methods and techniques. Thank you for watching.